All right, in problem 10, I'm trying to make you work for your money, right? I'm giving you 3 base traps. And like problem 9, you start with 1, right? We've got 1 base trap. And we know its central frequency right here. And we know when we reach the halfway mark that we're gone plus or minus, in this case, 8%, right? And we want another base trap. This is an orange base trap. We want another base trap that crosses over right there, right? And so we got another frequency. And again, I wish I'd drawn that better. Ooh, okay, we'll call that better, right? Plus or minus 8% from here. And then, because I love you, we have a third base trap that has to cross over at that same point. And the goal with all of this is to provide a relatively flat frequency response across a broader range, right? So you've got to start with this, and you've got to go down 8%. That's easy, right? So 8%, 0.08, you multiply by 1 minus 0.08, right, which is 0.92. Multiply by 0.92 from here, that gets you to there. Well, to go from here to there, to go up from here, you multiply by 1.08. So to go from here to there, you're going to divide by 1.08, all right, to go down. And then go from here to here, you're going to again multiply by 1.92. And then go from here to here, which is what I'm asking for, you're going to then divide by 1.08. So it's just walking down the chain to get to what is the central frequency on this lowest one, right? Because again, if this one's suppressing half from this direction and this one's suppressing half from that direction, then the actual response here is much lower, right? And again, here, the actual response is much lower. And so you get a relatively flat response across a broader range. All right, so let's get into this problem. So we have our frequency we're going to start with. I'll call that F1, 111.5 hertz. We have our percentage that we want to, that's our plus or minus range, 1.0, right? So I'm going to go down 1. So F50 down 1 is just going to be that, right, times 1 minus the percentage that we're going down. So now we know that frequency between the first 2 base traps, right? And so to get to the second base trap, we're going to have to take that frequency and divide by 1 minus there, right? Sorry, we're going to have to divide by 1 plus, right? We're dividing by 1 plus that to get down to where that frequency is. Why? Well, if we want to go from here to there, we're going to multiply this number by 1 plus that percentage to get up there. So to get from here to there, we take this number and divide by that, right? Okay, so F50 down 2, we're going to go down another step. Well, it's exactly the same thing we did up here. We're multiplying by 1 minus the percentage drop, right? So this frequency times 1 minus the percentage that we're dropping gets us to our new midpoint between the lower 2 frequencies. And then F3 down. It's exactly the same thing we did before. To go from F3 to F50 down 2, we'd multiply by 1 plus P. So to go from F50 down 2 to F3, we divide by 1 plus our percentage that we're changing things. And that gets us down to 80. And so we're looking for a frequency response that's relatively flat between 81 and 112 hertz, right? And it still has some effectiveness outside that range, but this is how we're combining these. And all of this is sort of an introduction to filters, which we'll cover in the last little bit of the semester. All right, that's it for problem 10.